Nikola Tesla, the father of wireless.
Part 3. Tesla's idea of longitudinal waves in the ether appear to be a direct outcropping of the research undertaken by Ernst Mach, who was still at Prague at the time. Mach's radical views on the relationship between consciousness, space and time, and the nature of gravity were beginning to alter greatly the thinking of a number of key individuals. His idea, which came to be known as Mach's principle, hypothesized that all things in the universe were interrelated. For example, the mass of the Earth, according to this theory, was dependent on a supergravitational force from all stars in the universe. Nothing was separate. This view, which Mach realized corresponded to Buddhist thinking, paralleled closely views espoused by Tesla. Although the following quote was written almost a quarter of a century later, its link to Tesla's 1893 lecture is clear. There is no thing endowed with life from man, who is enslaving the elements, to the nimblest creature in all this world that does not sway in its turn. Whenever action is born from force, though it be infinitesimal, the cosmic balance is upset and universal motion results. This idea was extended and interlinked between living organisms and inert matter by Tesla. All are susceptible to stimulus from the outside. There is no gap between, no break of continuity, no special and distinguishing vital agent. The same law governs all matter. All the universe is alive. The source of power which runs the universe is that found within the sun's heat and light. Wherever they are, there is life. As these processes were electrical in nature, to Tesla, the secret of electricity held the secret of life. Looking at the world around him, Tesla realized that it was a finite place and that the natural resources which gave humans the fuel to produce electricity would eventually run out. What would man do when the forests disappear? When the coal deposits are exhausted? He asked his Philadelphia audience. Only one thing, according to our present knowledge, will remain. That is to transmit power at great distances.
Man will go to the waterfalls and to the tides, Tesla speculated, because these, unlike coal and oil reserves, are replenishable. Having set up the premise that it could be possible to derive inexhaustible amounts of energy with properly constructed equipment, that is, to attach our engines to the wheelwork of the universe, Tesla described, for the first time ever, his invention of wireless transmission.
Cloaking his true goals in more palatable language, he announced, I firmly believe that it is practicable to disturb by means of powerful machines the electrostatic conditions of the Earth and thus transmit intelligible signals and perhaps power, taking into consideration the speed of electrical impulses. With this new technology, all ideas of distance must vanish, as humans will be instantaneously interconnected. First, we must know what capacity the Earth is and what charge it contains. Tesla also speculated that the Earth was probably a charged body insulated in space and thus had a low capacity. The upper strata, much like the vacuum created in his Keisler tubes, would probably be an excellent medium for transmitting impulses. We see here the precursor to the discovery by Heaviside and Kennelly of the ionosphere. Tesla had already thrust large amounts of electrical energy into the Earth to try to measure its period of frequency, but he had yet to come up with a figure that appeared accurate. Nevertheless, he knew the size of the Earth and the speed of light, and thus was already at this time formulating optimum wavelengths for transmitting impulses through the planet. During his talk, Tesla demonstrated impedance phenomena by turning on and off a light bulb by placing it at various positions along an electrified metal bar, based somewhat on the work of Hertz. This experiment demonstrated the concepts of wavelength and standing waves. He constructed circuits with 2 or 3 bulbs independently connected in a row, and placed metal bars at various points along the way, thereby illuminating or extinguishing one or another of these bulbs by impeding or not impeding the electrical flow. He also displayed electric lamps illuminated with only a single wire, and therefore was able to establish that the wire itself could be replaced by connecting the lamp directly to the Earth, which also was a conductor, as no return circuit as found in the Edison bulbs was necessary. As before, Tesla also displayed lamps illuminated with no connections whatsoever. With pure resonance, Tesla suggested wires become unnecessary, since impulses can be jumped from sending device to receiver. Naturally, the receiving instruments would have to be tuned to the frequency of the transmitter.
If ever we can ascertain at what period the Earth's charge, when disturbed or oscillates with respect to an oppositely electrified system or known circuit, we shall know a fact possibly of the greatest importance to the welfare of the human race.
Tesla proceeded to present a diagram which depicted how to set up the aerials, receivers, transmitter, and ground connection.
The son of one of his assistants described the apparatus.
In the transmitter group on one side of the stage was a 5 kVA high-voltage pole-type oil-filled distribution transformer connected to a condenser bank of Leyden jars, a spark gap, a coil, and a wire running up to the ceiling. In the receiving group at the other side of the stage was an identical wire hanging from the ceiling, a duplicate condenser bank of Leyden jars, and a coil, but instead of the spark gap, there was a Geissler tube that would light up when voltage was applied. When the switch was closed, the transformer grunted and groaned. The Leyden jars showed coronas sizzling around their foil edges. The spark gap crackled with a noisy spark discharge, and an invisible electromagnetic field radiated energy into space from the transmitter antenna wire.
To the receiver antenna wire, Tesla elaborated. When the electric oscillation is set up, he said, there will be a movement of electricity in and out of the transmitter, and alternating currents will pass through the Earth.
In this manner, neighboring points on the Earth's surface within a certain radius will be disturbed. Although Tesla's main goal was to transmit power, he also noted that, theoretically, and he would not require a great amount of energy to produce a disturbance perceptible at great distance, or even all over the surface of the globe. In Tesla's autobiography, written a quarter of a century later, the inventor informs the reader that there was such opposition to his discussion of wireless telegraphy at that time that only a small part of what IHAD intended to say was embodied in the speech. This little salvage from the wreck has earned me the title Father of the Wireless. Tesla stated that it was Joseph Wessler who told him to de-emphasize his work in wireless in this lecture.
Wessler probably edited out a number of key passages which, in the long run, could have helped Tesla establish more easily his priorities in the field.
Nevertheless, the entire Philadelphia speech runs 100 typeset pages and covers numerous other topics as well. What is important to realize is that for the first time ever, a major inventor announced bold possibilities in the field of wireless communication. Simultaneously, he explained in step-by-step fashion all of the major components that would be needed for success. The question of who invented the radio is complex, for there was no single developer.
Experiments in wireless can be traced back to Joseph Henry, who, in 1842, transmitted electrical energy across a 30-foot room between magnetized needles and sensitive Leyden jars, and to Samuel Morse, who sent messages in 1847 by means of induction across an 80-foot wide canal by using something called current leakage.
The first individual to transmit messages over long distances using aerials in the form of kites and a ground connection was Marlon Loomis,
a dentist and experimentalist who also used electricity to stimulate growth in plants. Loomis not only received a patent on the device in 1872, but also successfully introduced the Loomis Aerial Telegraphy Bill. Before the US Congress, Loomis made such an impact that $50,000 was appropriated to help him in his pursuit.
In 1886, Loomis sent wireless messages 14 miles between two mountains in Virginia, and a few years later, he also sent messages between ships 2 miles apart in Chesapeake Bay.
There is little doubt that Tesla was aware of Loomis. For one thing, his patent was registered, and Tesla always made it a practice to study the work of his precursors.
Also, it should be noted that some of the wording from Loomis's patent applications and published writings sound eerily like the wording in some of Tesla's discourses. For instance, Loomis discusses the passing of electrical vibrations or waves around the world, and principles of harmonics and resonance, and he also refers to harnessing the wheelwork of nature, a favorite term of Tesla's. In 1875, Thomas Edison, while working with Charles Batchelor, noticed an unusual sparking effect emanating from the core of an electromagnet which leaped to non-charged bodies several feet away. By using an electroscope, he was unable to distinguish a charge. In actuality, he had created a high frequency that could not be detected by his equipment. By charging Auger's main, Edison was able to obtain sparks from the fixtures in his house several blocks away.
Edison thought that since energy can take various forms, and it was possible to change electricity to magnetism, magnetism might be transformed into something else. Edison therefore announced to the scientific community that he had discovered a new unknown force.
Possibly, Tesla's ideas of connecting an oscillator to the water mains of acetate may have been influenced by this research. In the early 1880s, William Preece, electrical engineer for the British Post Office, began directing experiments in wireless communication by means of an inductive apparatus. He was probably also the first inventor to realize that the Earth itself was an integral component in the successful implementation of any wireless system. After isolating the role of the Earth as either a primary or secondary circuit, Pries utilized telephone receivers as detecting devices and concluded that, on ordinary working telegraph lines, the disturbance reached a distance of 3,000 feet, while effects were detected on parallel lines of a telegraph 10 to 40 miles apart in some sections of the country. Pries's work of detecting Earth currents, which was duplicated by Western Union engineers in the United States, significantly influenced the theories expounded by Tesla.
Pries had displayed a long-standing interest in wireless communications. He had visited Edison in the mid-1880s, just after Tesla emigrated to America, to witness firsthand Edison's latest invention, which he called the grasshopper telegraph, a device for jumping messages from dispatch stations to moving trains. By means of induction or resonance, a metal strip attached to a telephone receiver on a moving railroad car would send or receive messages from a similar strip strung parallel to the track at the station. Although the invention never evolved beyond this primitive early stage, the patent would later have important legal significance in priority battles over the invention of the wireless.
Thus, Edison is clearly one of the fathers of wireless transmission, as are Henry Morse, Loomis, and Pries.
Concerning the history of radio tubes, Edison also had an important invention, discussed above, of a dual filament label which displayed a flow of current between them, Pries having named it the Edison effect.
J.J. Thomson used it to help in his discovery of the electron, and Tesla combined information from this device with Crookes's work on radiation effects inside evacuated glass tubes to invent his brush phenomena, which was the first such vacuum tube explicitly created for wireless transmission of intelligence.
Other precursors to Tesla included Heinrich Hertz, Oliver Lodge, and Edouard Branly, a French professor of physics. Branly, perhaps influenced by the knowledge of the Edison effect, noticed that the gap of Hertz's tuned circuits could be replaced by a glass enclosed tube which contained finely scattered metallic particles. When current passed through the tube by means of wireless induction, the particles aligned themselves along the path of the gap and closed the circuit. A light tapping on the tube opened the circuit once again until transmission occurred.
Lodge perfected Branly's 1890 discovery of particle cohesion and labeled it the coherer.
These scientists were not thinking about wireless telegraphy at the time of their initial work.
They were explorers in a new field of electromagnetic induction, and it was not until 1894, by Lodge's own calculation, that he thought in terms of utilizing the equipment as a means of conveying information. On the other hand, we remember that Crookes, writing in 1892, at the very time he was meeting with Tesla in England, noted that he had experimented in the wireless transmission of Morse code from one end of a house to another at about the same time as Hertz and Lodge were experimenting in the late 1880s. But he never publicized his work or furthered the invention beyond this casual experiment. Tesla realized, as did Hertz, that the Hertzian frequencies through space were not conducive for long-range communication. But unlike Hertz, Tesla sought a way around this limiting factor.
Therefore, he devised not only the means of securing more powerful transmitters, but also concatenated tuned circuits, which were, in essence, sensitive radio tubes for receiving information. During their speech in Philadelphia, Tesla also introduced the concept of using both an aerial and ground connection and a single wire as a return for the operation of all kinds of devices.
This system of wireless transmission was outlined in detail in highly visible articles which appeared in 1891. During his first public demonstrations of wireless Geissler tubes at Columbia College in 1892 in Europe, and were explicitly delineated in 1893.
It would be another full year before a high school boy by the name of Guglielmo Marconi would begin his first tinkerings in the field.
End of Nikola Tesla, the father of wireless. Part 3. Thank you for watching.